Hello, Twitch. We're gonna officially start at 8:05, but hopefully everything is working, and if it's not, we have 4 minutes to figure out why. So let's see, I'm gonna pull this up on my phone. Can you hear me, Arvid? Great. Alright, it seems to be working. Oh, Arvid, can you post something in Discord, please? Saying that it's happening. So for those of you new to MIT time, everything starts 5 minutes after the stated start time and ends 5 minutes early. I don't know. People who have done Battlecode are used to that by now, but it's so we have 10 minutes between classes, which is something that you still need in a virtual campus. Not yet. Once things aren't broken. Oh, hello, Steam Blizzard. Life has been remote for MIT students for the past month. Yeah. Let's see. How can I want just the chat on this Twitch website. Maybe I need the app. Twitch. We'll get started in about a minute here. Just need to get people a chance to come on. If you are a pre-frosh, what's up? Welcome to CPW. This is probably one of the first events. I have no idea what CPW is going to be like this year, but you should do Battlehack. It'll be fun. Well, whatever. I'm just not going to monitor the chat very well. That's fine. Okay. All right. So, I guess it's time to get started. Let's welcome to Battlehack. For those of you who are participating for the first time, Battlecode is what we're usually called. Battlecode is a IAP class, which means it happens during the month of January, and you can get credit as well as win prizes and stuff if you're an MIT student. But it's a huge competition that we put on every January. There's like a real-time strategy game. It's like similar to StarCraft. You write an AI to control all the little bots and have them run around the screen and hopefully do intelligent things. From time to time, we run like mini competitions like this one, usually to test new engines and stuff like that, or sometimes just for fun. But this time, we're testing a new Python engine. We have internally tested it, so it's not like absolutely terrible. But I'm sure there are a bunch of bugs and exploits and stuff that we don't know about, so that's one of the reasons that we're running this competition. Generally, the way that it'll work is you'll write your bot to play the game that I'm about to describe, and then upload it to the website. It'll run some scrimmages against other bots, so you can see how yours performs compared to other people's. There'll be rankings and stuff. And then at the end, we're going to reset everybody's rankings, run a ton of games again, and then see what the final rankings are after that. However, this year there aren't just prizes for doing well in the competition itself, as in like placing highly and beating lots of other people's bots. This year we have 2 extra prizes, which actually have more money attached to them. So it's $500 for winning the tournament itself, but there's $750 at stake for people who can find major bugs in the engine. So I'll explain how the engine works in a second, but generally, like, doing things that are illegal, because that's not supposed to be possible, and we try not to make it possible. And then another $750 for being able to escape the sandbox environment entirely. So like, we are running whatever code you upload on our servers, and we think we're doing it safely, but it's possible that we're not. It's possible that you could run some arbitrary code on our servers and then escape the like protections that we've put in place, and then like be in our servers and be able to mess with stuff. If that's possible, we'd really like to know. And if you tell us, then you can get part of that $750 prize for like hacking the servers. All of this information as well should be on the the Getting Started page. That's not true. Tournaments page. This page. The different prizes and stuff. There may be more. We will decide eventually. All right, so without further ado, check the Twitch chat for questions and then launch into the game. Excellent question from Twitch. Can you just like play the game and not try to hack things? Yes. And you can still win $500 and the eternal respect of everyone involved, by just like making the best bot. And in fact, if you use hacks to win, then you'll be disqualified. So don't do that. You're supposed to tell us about the hacks and then not use them, and hopefully we'll fix them also. But we probably won't have time to fix all of them in the next week. But anyways, great question. Okay, so how does the game work? Well, over here on the Getting Started page, we now have the specs. So this, I keep wanting to say this year's game. This Battlehack is a prance of pawns, and the way that it works broadly is you're on a 16 by 16 chessboard, and you only have pawns. So pawns can move straight forward one piece, or they can capture a piece forward and right or forward and left and on the diagonals, but only one space. There's no fancy like first move double, no en passant, anything. Just move one forward or capture diagonally one forward. So yeah, you have pawns, and then every round, so each pawn gets to do one move, and then at the end of all the pawns doing their moves, you get to place another pawn on the back row of your side, anywhere you want. So a lot of the strategy is obviously going to be where you place those pawns, and how you move them, because you want to place pawns in the way of your opponent, but like you don't want them to get captured, stuff like that. I'll show some replays in a moment and it'll be clearer. But broadly, that's the way that it works. The trick here is the pawns can't talk to each other, and the overlord, which is what we call the bot that places the new pawns on the back row, can't talk to any of the pawns. So the overlord can see the entire board, but pawns can only see in a 5x5 square around them. And since the pawns can't talk to each other and they can only see a small part of the entire board, you have to be able to make locally intelligent decisions, hopefully to have globally intelligent behavior. This is one of the themes of Battlecode, is it's a distributed AI competition. So it's not just like StarCraft where you are the observer and you tell all of your units where to go and what to do and all of that stuff. Each unit has to decide for themselves what to do, and they have to make that based only on the very limited information that they can see around them. Again, the Overlord can see the entire board and place pawns wherever it wants on the back row, but once placed, those pawns are on their own to like figure out how to make a locally optimal decision based on what little they can see around them. So one of the things that you could do, hypothetically, to break the engine is to get pawns to talk to each other. So like if one pawn could see something that another pawn couldn't and could convey that information, that would be a pretty big advantage. So if you figure out how to do that, please tell us. But otherwise, if you're just trying to win the game, make good choices based on what the pawns can see. And then the Overlord has a lot of power in terms of where to place new ones. So as I was saying before, each round, where in one round every piece gets to move one time, is broken down into turns. So each piece, they don't all move at the same time. They go in spawn order. So whichever pawn was the first to be created gets to move, and then the second to be created gets to move. So all the pawns get to move once. They don't have to. They can stand still if they're in like a defensible position or something. But once they've all taken their turn, then each Overlord gets to spawn one pawn on the back of their team's row. So I mentioned the sensing thing already. Pawns can only see in a 5x5 square around them. There are a bunch of functions and stuff that you can use to like get the state of the board, which I'll show you later in example funcs player. And then movement. Pawns can only move forward one square or capture diagonally. Bytecode limits is, so for those new to Battlecode, bytecode is one way to measure the amount of computation that happens in a Java program. We got the name because the original engine was written in Java and we used bytecodes pretty heavily. One pretty clever dev last year figured out how to do something similar with Python, where instead of cutting each bot off at a specified time, which can be sort of unfair depending on like what else is running on the server, because like sometimes it's slower, sometimes it's faster, and just generally is like not deterministic if you do a time cutoff. So instead we use bytecode, which is deterministic because you get to run the exact same number of like basic level instructions every time. So if your pawn, looks at the 5 squares around it and then tries to take the square root of like a gigantic number, it'll run out of compute and we'll cut it off at the same time every single time. And this is to protect, or not to protect. This is to make sure that you're being efficient and to also add sort of another constraint on your optimization problem here, which is you only get 20,000 bytecodes per turn for every unit. So pawns will probably not use too much of that, but the Overlord, maybe if it scans the entire board several times, could get up closer to that limit. So you also have to make sure not only that your code does intelligent things, but that it's efficient. And if you don't understand the intricacies of bytecode, that's all right. The whole point is just that it's a way to limit the amount of computation that you're doing. And if you run out of bytecode, your bot won't crash. It'll just get paused, and then it'll resume in the same place next turn. So if your Overlord uses 20,000 bytecodes doing some really intelligent strategy, it won't spawn a pawn that turn. It'll just get frozen, and then it'll resume the next time and hopefully spawn a pawn that turn. You never want that to happen, right? Because you want to be able to spawn as many pawns as you can. Definitely a big advantage in numbers. But that's how it'll work. And you can tell, we give you a get bytecode function, so you can tell how much bytecode you have left and stuff like that. In summary, this is a quick reference to the whole API. So all of the functions that you can do, these ones you can do as both pawns and overlords can do this. Only the overlord can get the entire board state and call the spawn function. And then only pawns can do the capture, get location, move forward, and sense, which returns a list of visible robots. We call them robots, other pawns. there are some already known bugs and limitations which we have listed. But again, if you find new bugs, please tell us. Okay, so how to actually do this? Well, handily, right below on our Getting Started page, you first need to install pip. So I already have it pip, so I'm going to skip that one, but it should be pretty straightforward on any operating system. If you need help, feel free to ask in our Discord, which everyone should join. There's a link right here, Discord. So join that, ask questions. We'll be around to help answer your getting started questions and other stuff. But anyways, install pip. And then once you have pip, got to install the Battlehack 20 package. Whoops. So I'm also, for anyone new to Battlecode and like terminal usage, I'm going to be using the terminal a lot. This is just a way to input commands into your computer. For example, pip3 install Battlecode or Battlehack 20. So you should be able to do that. It will download the stuff. I think I already installed it, so it was pretty fast. And then what you want to do is you want to get the Battlecode scaffold or Battlehack scaffold over here. So I am going to clone this with GitHub, another very useful tool. If you don't know about Git and GitHub, check out this guide right here. It's really cool. It's what all programmers use to collaborate. Don't use Google Docs. I've made that mistake. Okay, anyway, so Git Clone is just going to download this repo, essentially. When you do this, you should first make a copy of this repo, which, again, we talk about in here. We recommend that you use it as a template and then make it private. That way you can start with this example code and collaborate with your team. But for the purposes of example, I'm just going to clone it. So now if I go into Battlehack 20 scaffold, I can see what files are in here. Example funcs player, license readme run.py. Perfect. Okay. And then, so get the scaffold, and then that should be it. So now you can run matches like this. So if we just do Python 3 run.py, and then we can run example funcs player versus example funcs player, and well, darn. Oh, I didn't pip install. Did I not? All right, hold on. Let me try this again. Pip install. Already satisfied. Python 3. What? That doesn't seem right. Okay, well, I might have messed this up because I was already installing old versions of the package before it was ready. But I can still show you what happens. So instead, you should use the scaffold, but because I have broken things, I'm going to use an older version, or I'm going to use the source code version. So let's try that again. Run.py, example funcs player, example funcs player. So this is what is going to happen for you when the install works correctly. And then, oh, my screen is too narrow. Hold on, let me try that one again. So what's happening is example funcs player is one of the example bots that this comes with. So it's right here. And all of those gigantic print statements was like the debug print statement. So you can log stuff in your code and it'll print it out so you can see what's going on. It's very useful for debugging. It also prints some game information like, the turn queue or what turn it is, stuff like that. And then it'll show you what's happening. So black is on the bottom here. You can see pawns being spawned, black pawns being spawned at the bottom, white pawns being spawned at the top. And they are moving up the board. The black pawns are moving up the board, white pawns are moving down the board. From time to time, they'll capture each other like that. So that was cool. And, oh, I never said the objective of the game. Okay, so the whole point of this is to get as many pawns of your color to the other side as you can. So this game, white won because they got 8 pawns to the back row of black. So 8 is the threshold. If the game ends before someone gets 8 pawns, because there's a turn limit at 250 turns, it's whoever has the most pawns on the back row wins. But anyways, so yeah, we can watch the replay again because that was cool. This is running example function player against example function player. Lots of print statements and stuff happening while it runs the game. And then this is what it looks like this is what a visualization of what happened. So we can see there's a lot of conflict over here. Pawns taking each other. Example function player's strategy is pretty bad. It just randomly spawns pawns on the back row and then always moves forward if it can, even if that would put it in danger. So like this one, you'll see they'll run into each other and then one of them will just die. Seems like it could be improved potentially. But yeah, so this is what the game looks like. If you want to see sort of what your bot is thinking while it does this, that's what all these print statements are for. So we have a bunch of example print statements in example function player that have all this information, like, this is a pawn at 6-6, and then it captured something else at 7-7, and then it finished its turn with still 19,000 bytecode, because this is a really simple strategy. So those are all the print statements that you'll want to use for debugging, figuring out what your pawns are thinking, why they're not being as intelligent as you think they should be, etc. But yeah, and you'll notice that this game actually ended the exact same way as the previous game, with all the pawns still in the exact same positions and everything. And that goes back to the bytecode thing, where because the computation isn't being cut off on a time limit or something, every time you run the exact same 2 pieces of code against each other in the same positions as white and black, the game will run exactly the same way, which is super useful for debugging. Because like if I wanted to see why pawn 47 ended up here, and it happened in this game, I could add some print statements to like try to find this case and then run the game again. And just adding print statements shouldn't change anything unless you're running out of bytecode. So then the game would happen the same way. The print statements would go, and this time I'd be able to see why exactly pawn 47 ended up where it did, for example. Okay, I'm going to go back to Twitch for a second just to see if there are questions. Okay, let's see. Oh yes, we do not support Python 3.8. We're not. We're thinking about it. But yeah. So good question from Jira Y plays. What happens if 2 pawns try to capture each other at the same time? So the answer is that actually can't happen. So every frame update on the visualizer is like 1 round, but inside 1 round, each pawn actually gets to go sequentially. And that's why these numbers matter. The numbers are the spawn order, and they actually get to move in spawn order. So next turn, let me see if there's a good example of this. Yeah, so next turn, like this white pawn, 62, will take its turn first. So it's stuck, it can't really do anything, so it's just going to stay in place. And then some other pawns will go, and then this pawn, black 75, will take its turn, and because it's dumb, it's just going to move forward 1 step into danger, which it could have predicted, right? This pawn can see a 5x5, oh, that's a bad way to highlight this, but it can see a 5x5 square around itself, so it can tell that this white pawn is here, and it's in danger. But because it's example function player, it's going to move forward into this space. The white pawn has already taken its turn this time around, so that black pawn will survive at the end of this round. But then next time, the white pawn gets to move first, so the white pawn will capture b75 here before b75 gets to take another turn, if that makes sense. Okay. Oh, I'm supposed to show Python 3-i example function player. Okay. Great. Oh yeah, good question, Jira Place. The spawn order is global, so there will never be a white 1 versus black 1. It would be white 1, black 2, and then I think it's snake order, which is like intentional. So it would be white 1, black 2, black 3, white 4, white 5, black 6, black 7, or maybe vice versa. I don't remember if they just alternate or if it's snake order, but we can get back to you on that. But anyways, yeah, the numbering is global, so there will never be a white and black pawn with the same number. Okay, Twitch chat says I should do Python 3-I example funcs player. So I guess I'll do that. What? I don't know. I don't know who told me to do that, but it doesn't look like it works. There is, I think, maybe it's my setup or something, but I think there is a way to actually play by hand, or at least step through turn by turn, which is documented somewhere on this site, I think. And if it's not, it will be soon. Probably a debugging page coming soon or something like that. Yeah, if that's not up already, we'll make sure to put it up. But anyways, okay, so that's the game. That's how you run matches. That's what they look like. Just so you see what an example piece of the code looks like, and sort of how easy it is to get started, let me show you example funcs player. And you can use any editor you want. I like Sublime, but you can use whatever you want. So this is what it looks like. Bot.py is the name of the file that you need. And this is an example bot. So the most important thing here is this turn function. So every bot needs a turn, and this is just what it will do on its turn. The way that it gets information in is every turn, the engine will call this function, and you can do things like get the board size, get the team, which don't change on different turns, but you can like get location if it's a pawn. So here first we're doing is team equals get team, and then some logic based on that, we'll print it out. And then robot type equals get type. So now we can say if robot type equals robot type dot pawn, then do pawn things. So like get the row and column of the current position, print it out. If your team is white, then forward is down, otherwise forward is up. That's just some logic. And then it says, okay, check forward one row and over one column. So this is up and to the right. So can this pawn capture a pawn of the opposing team? So the way that opposing team was generated is if your team is black, then opposing team is white. Otherwise, opposing team is black. So if the so check space just says, oh, what unit is at this space, and if the team is the opposing team, then you'll capture it forward one and over one column to the right, and then it does check space for column -1, so to the left also, and then if all else fails, we'll try to just move forward one space. So this checks. You don't want to move off the board, and then it checks the space directly in front of it, and if there's nothing there, then move forward. And then the pawn, that's the end of the pawn's turn. So this else is up here with this one. So if it's not a pawn, then it's the overlord. It checks the team, and then it just loops over all of the things at the bottom of the board and chooses a random number. If there's nothing in that space, then it will spawn a pawn there, and then once it does that, it will end its turn. And then at the end of both of their turns, you check the bytecode and print it out, just for fun. You don't have to do that. So all of these functions, like the move forward check space. So we provide a useful wrapper function because check space can throw exceptions, and if you get an exception and you don't handle it, then it just ends your turn right there. But like check space, get board size, move forward. That's how you get information about the game and how you perform actions and stuff like that. So this is an example player. It's not very smart. It always captures and moves if it can. And then it just spawns things randomly. But if you you can take this code, you can modify it, add something more intelligent, maybe like only move forward if you're not going to die as a result. Seems like a good initial improvement. And you can use all these same functions, the check space function and everything, to figure out, what teams are where and if you're in danger and stuff like that. So great. So that's example funcs player. Feel free to modify this. It's here for you to see an example bot. And this is all it takes. So this is like 70 lines of actual code, and already it performs some vaguely intelligent behavior, playing a game against itself. You can also run two different bots against themselves. So for example, if I had another player, I could do run.py example funcs player and then my bot or something. You just change the arguments here. But that's pretty much it for getting started. Let me see if there are any questions. I'm sure I missed something. Let's see. Can you win for free? No. Although if you figure out a way to just make yourself win by hacking the engine, then tell us, please. Nathan is insulting his own dashboard. Okay, is PowerShell a viable terminal environment? Yes. So you should be able to use any terminal that can run Python. So one thing to think about if you are on Windows is the colors and stuff are kind of off. So we added a flag for disabling the colors, and that makes everything work fine in the Windows terminal. But that's something to watch out for. I think that's on the common problems page or something. If it's not, we definitely need to add that too. What are the two things I said we needed to add? We needed to add, the python-i thing. Add python-i, add flag to disable. I just want to make sure these things are on the website. Add flag to disable colors for Windows people. Great, this is not Python code. Okay. All right, great. Any other questions from Twitch? Can we assume, where is it? Can we assume the module context remains loaded between turns, or is the turn self-contained? I don't know exactly what you mean by Luderguff, or I don't know exactly what you mean, Luderguff, by assume the module context remains loaded between turns. But I would just keep it the way that it is in example funcs player, where each turn you load the information that you need to know, like the board size, whatever. That's not going to change between the beginning and end of your turn unless you run out of bytecode. If you run out of bytecode, everyone else gets to move, so things could change positions, and that would totally mess you up. So be careful of that. But otherwise, none of this state can change during your turn because each pawn takes their own turn one at a time. And yeah, great. Okay, great. Thank you, Quinn. -- raw text is what you need for not having colors. Raw text, apparently. Let's see. Yes, amazing. Oh, and so this will just print them out sequentially. The bottom one is the current frame. They're just printing one at a time. So if I put stuff in the middle, the next one prints. Yeah. Yeah, so this is what you should do. If when you run the game, you get lots of weird looking symbols and stuff, add that -- raw text flag, and you'll get it printed out like this. This is also how the replays will... does it say that in the spec? Oh, never mind. Sorry, okay, so I'm going to answer a question first. Someone asked, once the pawn gets to the end, does the pawn disappear, or is that lane finished? The answer is that lane is finished, which is important, because if you fill up an entire lane with pawns, and then one of them gets to the end, the other ones become, like, way less useful, because, you know, they're just sort of stuck behind that one. So it's important to, like, balance your pawn placement well between many lanes, so that once you get to the top of one, you're not, like, blocking yourself for later ones. That's a good question. Yeah, so like right here, this white, these stack of 4 white pawns are like pretty much useless. They're actually totally useless, because now black can't spawn any pawns right here. So these ones will never be able to capture anything. I mean, I guess black could spawn something here and capture sideways, but regardless, these white pawns are kind of useless now, built up behind this one. All right, great. What was I saying before? Oh yes, this is how replays are saved. So with the with the raw text flag, you get these like board printouts like this. And this is what you'll get as a replay file. So on the website, when you go to upload your bot, so you go to submissions here, submissions will be enabled soon, but you'll be able to click a button, upload your folder. It'll have instructions on here, and then go to your, well, there'll be a scrimmages tab also once those are live. Oh, my secret key is in the stream. That's sad. Okay. Well, regardless, I guess everyone can join. No one can join because there are already 2 people. So there. Anyways, these are the rankings. Some people have already made teams, but the score will change based on your scrimmages and stuff as those get up and running. And let's see. Yes, and once there's a scrimmages tab, you'll be able to see all of the games that your team has played and download this file, which has all of the debug statements and stuff like that, and then all of the frames of the game, so that you can see what happened. I think we're also working on a tool to like take this thing and turn it back into the nice, like, you know, motion moving picture thing magic. But this is what it looks like at the moment, and you'll be able to see that from all of your scrimmages and stuff. Okay, what else was there? I'm gonna run another game while I check the list of things that I said I should talk about. Let's see. Okay, great. So I think that is it. Welcome to Battlehack. If you have questions, bring them to the Discord. We will be around to answer them. Also, feel free to answer other people's questions. Good luck. Make sure you go to battlehack2020.battlecode.org. Register, form a team. Teams are 1 to 2 people this time. Instead of the usual 1 to 4, just because, I don't know, it's only a week, it's a simpler game. Maybe you can split up your usual Battlecode team and see who's actually the best. But anyways, go to bh2020.battlecode.org, register and stuff, form a team, download the scaffold and everything, and good luck. I'm going to check for questions first. So that was so anticlimactic. Oh, would it be possible to do a rush strategy? Where a bot could spawn a few pawns and push them to the end of the board? Yes. Sort of. I mean, the pawns can only go so fast, and I don't think you would usually want to not move them But yeah, I don't know. It seems, yes, I agree with DJ and Etro that moving your pawns to the other side seems like a good strategy. Okay, great. All right, let me try again. So that's Battlehack 2020. Good luck. Join the Discord, ask questions, find teammates, and make something better than Example Funks Player. Until next time.